Question 12, Part C. The point P, 2AP, AP squared, lies on the parabola x squared equals 4ay. The focus of the parabola is at S, 0, a, and the directrix is the line y equals -a. The vertical line through P meets the directrix at M. The tangent at P meets the y-axis at R. Show that angle SPR equals angle SRP. We want to show that triangle SPR is isosceles by showing SR equals SP. So if we can show that that triangle is isosceles, then the base angles must be equal, and those base angles correspond to the two angles that we're trying to prove are equal. So let's start. The gradient of the tangent at P is the parameter P, and the equation of the tangent at P is y minus AP squared is equal to P times x minus 2AP in brackets. So this is using the point gradient formula. We'll call this equation number 1. Now the y-intercept of the tangent corresponds to the point R. So from equation number 1, I'm going to let x equal 0, so I'm going to let that equal 0 here, and then solve for y. So y minus AP squared is equal to P times 0 minus 2AP in brackets. And that simplifies to y minus AP squared is equal to negative 2AP squared. Adding AP squared to both sides of the equation, we get y is equal to negative AP squared. And that corresponds to the y-coordinate of point R. Now, the length of interval SR is equal to A plus AP squared. And using the distance formula to find the length of SP squared, we use x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared. So that's 2AP minus 0 in brackets squared plus AP squared minus A in brackets squared. Expanding the brackets here, we get 4A squared P squared plus the expansion of this perfect square. So that's A squared P to the power of 4 minus 2A squared P squared plus A squared. And that simplifies to A squared P to the power of 4 plus 2A squared P squared plus A squared. We get that by combining this term with this term, since they are like terms. Now we can factorize out A squared from these three terms, and we get A squared times P to the power of 4 plus 2P squared plus 1 in brackets. Now this is a perfect square here in expanded form, so we can factorize what's in brackets here, and we get A squared times P squared plus 1 in brackets squared. Now the length of SP is equal to the square root of SP squared that we just found. So taking the square root of A squared times P squared plus 1 in brackets squared, we get SP is equal to A times P squared plus 1. Expanding the brackets, we get A plus AP squared, which equals SR. Hence, triangle SPR is isosceles, since we've just proven that two sides are equal. Therefore, angle SPR is equal to angle SRP, and the reason is base angles of isosceles triangle SPR.